Okay, the very final, fundamental, just for the very last time, very quickly, let's ask ourselves, let's take a third set C, and we're going to ask ourselves how many total subsets of C are there? Well, the reason I'm doing this example is because I want to really have you notice to not care about what the elements are. Just care about the number of elements. That's all that matters in counting questions, really, at the end of the day. So here we have a mixture of letters and numbers, and the numbers aren't all one digits, they're large, they're 90, right? We have C is a set that contains the elements A3, 90, Y7. So how many subsets are there? Or, better question, what is the size of the power set of C? And that's going to be 2 to the power of n. N is going to just be the number of elements C has. How many elements does C have? We just need to count each element once. We need to make sure we count all of them. So we'll start 1, 2, 3, 4, 5. N here is going to equal to 5. So we're asking 2 to the power of 5. Not asking, we're saying that the total number of subsets is going to be 2 to the power of 5. Now we did compute this. This is equal to 32. Let me just, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, and then 2 to the power of 5 is 32. Yes. So in our counting problems, I'm not going to care if we get to a number at the end. I am happy with just leaving the answer as 2 to the power of 5 or whatever the answer ends up being. Because the point is that we get an equation, whether it's a number or just like this number plus this number minus that number. I'm not going to care to compute the sum or the product of it. I'm just going to care that we get the number, right? So I'm just going to, from this point forward, accept an answer in the form of this. I'm not going to ask or care to get it into something like this, because this is going to be the same as saying 2 times 2 times 2 times 2 times 2. These are all the same, so we should be happy with this just as much as we're happy with this. So there we go. And from the second video, you should trust me that this is in fact true, because we've done 2 examples, one large example, one small example, where this formula seems to hold true. Fantastic. So we find that the total number of subsets that C has is going to be 2 to the 5, regardless of what the elements are. We don't care if they're all numbers, if they're all letters, if they're all people, if they're cars, buildings, whatever is in here, we just care about the number of elements. The elements don't all have to be the same.